In the last video, we looked at the trigonometric function of sine theta in a lot of detail. And we looked at the basic form of the sine theta graph. And we looked at what the effect of A and Q are on the appearance of that graph so that we could easily sketch any sine graph that we were given. And in this lesson, we're going to do the same thing, except we're going to be looking at the cosine theta graph. The basic form of a cosine theta function is f of x is equal to a times cos theta plus q. This is the same thing that we saw with sine theta, except here we're dealing with cosine theta. So the effect of A and Q are going to be very similar to what we saw with the sine theta graph. And the only differences are going to be based on the inherent differences between the appearance of the sine and cosine graphs. So let's take a second to quickly sketch out the most basic form of the cosine function, which is just f of x is equal to cosine theta, where we have an a value of 1 and a q value of 0. So here in green we have the cosine theta graph, and there are a few key points over here that we can recognize. Over here at 0 degrees, this is our 0 degrees point here. And when we have a theta of 0 degrees, our cosine of 0 is going to be 1. So at 0 degrees, our cosine function has a value of 1. Over here, we are at 90 degrees, or pi over 2 radians. And at 90 degrees, the cosine function is going to take on a value of 0. Here we have 180 degrees, or pi radians, and at 180 degrees, cosine of 180 degrees is going to take the cosine function to its minimum value of -1. At 270 degrees over here, or 3 pi over 2 radians, the cosine function at 270 degrees is again going to be 0. And at 360 degrees, or 2 pi radians, the end of our period for our cosine function, the cosine function is going to reach its maximum value of 1 again. And if any of this is unfamiliar to you, I recommend you go back to a few videos ago when we looked at the sine and cosine graphs in more detail. And we can recall from that video that these were some of our special angles that we memorized so that we were able to commit to memory the most simple cosine graph. And knowing these few points is going to allow us to easily sketch out any cosine graph if we keep in mind what our effect of A is going to be and what our effect of Q is going to be. So let's take a quick second to look at the effect of A and the effect of Q. Q is going to represent our vertical shift. This is what we saw with our sine theta graph as well. And just like that, our Q is going to represent our vertical shift. And that means that if we have a Q value greater than 0, our curve is going to shift upwards. And if we have a Q value less than 0, our curve is going to shift downwards. So your Q value is just going to shift this curve upwards or downwards. A is going to affect our amplitude. So if we are going to have an A value greater than 1, we are going to increase the amplitude of our graph. And to recap, the amplitude of this graph is going to be the distance from baseline to the crest of the wave. So it can be this distance here, or the distance from baseline to the trough of the wave. So it can also be this distance here, and these are meant to be the same value. The amplitude of our basic cos graph, and the same goes for our sine graph, is going to have a value of 1. So we're going to go up 1 from baseline and down 1 from baseline to get to our maximum and minimum values. So if we have an A value greater than 1, we're going to increase the amplitude of our graph. And what that means is that our amplitude, which I'm just going to make a note of here, this is the amplitude. Our amplitude is going to increase, which means that this graph is going to stretch in appearance. So in red, I'm going to draw in what this curve would look like if we had increased the amplitude. We're going to have higher maximum values. We're still going to be reaching 0 at the same points we did in our basic curve. but we're going to have higher maximum values and lower minimum values. And I apologize if this looks very wonky. It's meant to look exactly the same as this green curve, except it has higher maximums and lower minimums. But it's still going to be 0 at these key points over here when we have a Q value of 0. In this case, we're only going to have an A value that is greater than 1. So we're going to have an increased amplitude, but with this red curve, we're still going to have a Q value of 0. So these points are still going to remain the same. All that's changed is that we've increased our max and decreased our min, and those are going to increase and decrease by the same factor. Now let's take a look at what would happen if we had an A value in between 0 and 1. If we had an A value in between 0 and 1, in other words, we had a fraction, we had something less than 1 but greater than 0, we are going to decrease our amplitude. And this is the same thing that we saw in our last lesson with the sine graph. And a decrease in our amplitude is going to look something like this. I'll draw that out in blue here. So if we decreased our amplitude, we would have a lower maximum. We would still be reaching this point here. We would have a lower minimum, and it would look something like that. So this is what our curve would look like if we decreased our amplitude. We flattened the appearance of this cosine graph. So that's what would happen if we had a fraction as our A value. Now, what if we have an A value that is less than -1? If our A value is less than -1, we're going to increase our amplitude. But because our A value is negative, we are going to have a reflection of this curve about this axis over here. So what would that look like? Let's take a second to quickly draw out two different versions of this cosine graph. And in this case, we're going to have a positive A, and in this case, we're going to have a negative A. So when A is positive, our cosine curve is going to take on its normal appearance. It's going to look something like that. But when A is negative, our cosine curve is going to look just like this, except it's going to be reflected. So it's going to look like an upside down version of this. So this is what we would get if we had a negative value for A, and this is what we would get if we had a positive value for A. So when A is less than -1, we're going to increase our amplitude, but we're going to have our curve that's going to take on this appearance. It's going to be reflected. If we have an A value that's in between -1 and 0, in this case, we have a fraction, but it's a negative fraction. We're going to decrease our amplitude, but our curve is going to look like the reflected version. So again, it's going to look like this because it is a negative A. So this is exactly the same trend that we saw in our last video with the sine theta graph. When we have a whole number for A, when it's not a fraction, it's going to increase our amplitude. So we're going to have an increased stretch of this curve. But if it's positive, it's going to look like this, and if it's negative, it's going to look like this. If we have a fraction as our value for A, we're going to decrease our amplitude. So it's going to flatten the appearance of this curve. And if it's positive, it'll be shaped like this. And if it's negative, it's going to be a reflection. So this is the same thing that we saw with our sine theta graph. So this trend of our Q being our vertical shift and how A is going to affect the appearance of the basic graph is the same with cosine and sine. The only differences are inherent in the differences between the shapes of our basic sine theta graph and our cos theta graph. And in the next video, we're going to take a look at an example and apply what we've learned in this video to that example. And we'll see that in doing that, we're going to be able to easily sketch any cosine function that is found in this form.